Hey, this is Doctr Night Class. Go ahead and click like and subscribe below. Hope you enjoy the medical content. All right, so we're bringing forth another image again. Okay, this is vesicular transport. So the transport of vesicles, right? And we talked about how that happens in a cell. We talked about it quite a bit. We talked about it from how it starts inside the nucleus, how it's packaged, right? It's packaged by the Golgi apparatus. It's sent down the microtubule for exocytosis by COP2 kinesin, right? So all of those are still in motion. Then it leaves the presynaptic cleft with the help of influx of calcium. Okay, and the vesicle is holding the neurotransmitter inside. And a neurotransmitter is nothing but an amino acid that's been post-translationally modified, right? So either we hydroxylate it, we glycosylated it. There's a lot of ways we can do post-translational modification. So when these vessels leave the presynaptic cleft, they're in the synaptic area, okay? And from this area, they can act on the postsynaptic cleft. And they're going to influence it to do one of two things. You can either depolarize and stimulate action and excitement, or you can repolarize and you could be inhibitory, right? And we have certain ions moving inside the cell and out of the cell. Depolarize, it's sodium or calcium moving in. Repolarize, it's either chloride moving in or potassium moving out. Okay, so the cell becomes more negative or more positive or more negative, right? So what does that pertain to our axon? So our axon or our neuron here, our neuron has two components. It has this blue portion here, which is reflective of the nucleus, and you have some nissl bodies, which is reflective of the ribosomes, which we'll talk about. Some dendrites here. We'll talk about that specifically. Okay, and this is considered the cell body unit. Okay, so this is where the neurotransmitter is made. All right, now it's going to exit and it has to travel down the microtubules, which are inside the axon. Inside the axon, you have these microtubules that are carrying the vesicle that has the neurotransmitter. It's going to take a lot of energy, a lot of ATP to carry the vesicle down these microtubules. It'll take a lot of energy to carry the vesicle down the microtubules. So you can expect inside the axon, there's going to be a lot of ATP generated. You may even say there's a lot of mitochondria. There's a lot of mitochondria because mitochondria has electron transport chain. It can make a bunch of ATP for us. So we can move the vesicle down the microtubule. Okay, so when we get further into histology, we'll see if the axon has a bunch of mitochondria in it. That'd be useful. Okay, now the vesicle is going to leave through the presynaptic terminal and influence a structure. It can be a visceral organ. It can be a somatic organ like skeletal muscle. Okay, so there's different ways to go about it, but I've lined these up as close as I can to show that they're pretty much the same thing, guys. Okay, it's just a different area of the body. That's all. It's just in the brain now. That's all. So I want to zoom into this image. So let's close this and stretch this out here. Looks good. All right. Okay, so let's start here. We have the cell bodies and we have this dot inside the nucleus, this really dark dot inside the nucleus. There's only one thing it can be. It's the nucleolus. Don't forget about the nucleolus. The nucleolus is that dark structure inside the nucleus. And the only thing the nucleolus does, it has one job. It has one job. Okay, so you see the green arrows pointing to the nucleolus. One job. The nucleolus makes RNA-based protein. That's it. Makes RNA-based protein. Okay? So, RNA-based structures and proteins. What is an RNA-based one? A ribosome. A ribosome, right? You make ribosomes from RNA, right? You make ribosomes from RNA. So, this nucleolus, that's what it's doing. It's making RNA-based proteins like a Nissl body. A Nissl body is just a ribosome that lives in the neuron. That's it. It's just getting a special name. A Nissl body is a ribosome that lives in the neuron. So what does the ribosome do? Let's take it all the way back. The ribosome is going to take messenger RNA, which it got from the nucleus, and it's going to translate that and make some type of protein. Maybe it'll be folded, right, by a chaperone. That's fine. But this is what is occurring at the Nissl body. You're folding a protein. Maybe there'll be some post-translational modification because we know that neurotransmitters are going to be released in these vesicles. And we know how to make neurotransmitters. We take an amino acid and we do some post-translational modification, right? Once we get that vesicle, we send it down the axon, we slide it down the microtubule. Okay, so that's all of the contents we're looking at here. In red, these granular dark stained areas, these are the ribosomes. We call those ribosomes Nissl bodies. That's it. Everyone wants to be famous. If you want to be famous, take the same product and you give it a different name. That's what we do in anatomy, right? That's all they're doing, right? They could have given this nucleolus a different name because it's neurology, it's special, right? They could have, but they gave these ribosomes a different name called the Nissl body. And now we know what they do, okay? So we've made our neurotransmitter, we've put it inside a vesicle, and we're shipping it down the axon over here. Within this axon, let's take a cross section of this axon. Everyone chop up some axons, right? We know what's on the outside of the axon. We got myelin because we want the transmittance of the signal to go quickly. So we wrap myelin around the hot dog. We wrap myelin around the axon, okay, to make it bigger. So this structure, it has to be myelin. This has to be the myelin. This has to be the hot dog bun, right? And there has to be microtubules in there. There has to be microtubule. Is a microtubule a filament? Does anybody remember? Microtubule filament? I think it is, right? All those cytoskeletons, they're just a bunch of filaments. They're just a bunch of filaments, okay? So you're seeing here, they're calling this a neurofilament, right? And this is a microtubule. Can you say it's pretty much the same thing? Yes, because there's one responsibility of the inside of the axon. The inside of the axon has one responsibility. Get that vesicle with the neurotransmitter to the presynaptic cleft. That's your only responsibility. Okay, now let's look deeply, and we were right. We need a lot of energy to get the vesicle down the microtubule. A lot of energy. So we have a mitochondria sitting right there. So it's happily ever after. We can do electron transport chain here, make a lot of ATP, so we could send the vesicle down the microtubule. Now let's look at it this way. There's a mitochondria in the axon, right? There's a mitochondria in the axon. To use a mitochondria and maximize ATP from electron transport chain, you have to be in an aerobic environment. An aerobic environment, right? So If you're in an anaerobic environment, are the axons going to suffer? Yeah, because you can't do electron transport chain. You can't make ATP, and you can't get those vesicles with the neurotransmitters down the axon. Okay? Remember, guys, hold on to all these concepts. You group them all together, and you create your own connections, right? So when you come to the exam and they're explaining something, it's like opening a toolbox. They say, oh, build a house. Okay, hand me the hammer. I need a Phillips screwdriver. Okay, you don't know what you're going to use on these exams. What you want is a toolbox full of concepts. Okay, that's what you want. All right, so let's go. So these circular structures have to be nothing other than vesicles. Vesicles that are carrying the neurotransmitters. They're going to meet at the presynaptic cleft to be released, okay? And they'll communicate with another cell. For more night class content, go ahead and email me at doctrnightclass@gmail.com. That's DOCTR nightclass, gmail.com. Hope you enjoy the content.